In this video, we're going to reverse engineer this brake lever using prismatic features in Fusion 360, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, part 3 of our series, we are going to carry on working with this KTM brake lever mesh data. Now, in the two previous videos, we looked at mesh section sketches, which you can see there are quite a few down here. I'm going to go ahead and create a group, kind of combine all those things together. And then we looked at using freeform modeling, which was a much simpler approach to using the mesh or scan data and creating a good, clean quality surface. So now in this video, we want to talk about a third method that we're going to use to reverse engineer this part. Now, I've had a couple comments come in about wanting to see how I would finish off the design using mesh section sketches or using the forms. And a little bit of a spoiler, I'm not going to do that. Now, the reason I'm not going to do that is because I've actually done it before and the end result is not good. Now, when we looked at the mesh section sketches, just for a little bit of background, if you haven't watched the first two videos, the mesh section sketches were a great way to capture the mesh data specifically, but we did end up with a lot of basically unusable splines. Now, the splines or the quality of the spline just wasn't great. If you're going to 3D print something or you're not looking at fabricating it at really high precision, it's probably fine. But the quality of the freeform surface was much better because there were only a handful of points that were snapping to the mesh, and we weren't looking at trying to accurately represent the mesh with a spline. So because of that, transitioning from either of these, honestly, from the freeform spline or from the mesh section sketches to some of these more prismatic features, it's just not going to end well. The transition between those features down to the surfaces is just going to be bad quality. And what I mean by that is there are going to be issues with surfaces where if we try to thicken them or offset them, they're going to fail. So what we're going to do instead is we're going to take a look at basically recreating this with prismatic features, essentially the way that you would model it from the start. Now, when we're doing this and we're reverse engineering parts, we basically have to think about the design intent. We have to go through and try to understand what the designer was thinking, what the requirements were for the design, and we're going to use that to our advantage. So with a design like this, if you want to follow along, go to the description of the video. You can go ahead and download the data set. It will contain both the solid body from the mesh section sketch, and it will also contain the surface from the freeform. So if you want to look at those or play with those, you certainly can. But what we're going to do is we're going to take a look at this as if it were prismatic features. So for the most part, this backside here is a consistent thickness. And that consistent thickness goes up until we get to this little bump out here. So what we're going to do is we're going to basically create an extrude of this entire body, and then we're going to use a sketch on, let's say, the front plane, and that is going to allow us to have it bulge out and come back down. And then we can use true fillets to round off the corners and so on. Now, because of that, what we want to do is this section here, I'm going to go ahead and pull this around. This section here where it sort of flares out into this hook, this height right here is essentially the same height as this over here. So we're going to come back to this part later. Now, I will have to say that I haven't modeled this yet. I haven't gone through the process of doing this with prismatic features, but this is the approach that I'm going to take. Now, I know my videos tend to be a little bit long-winded, and I try to put in as much information along the way that, the things that I'm thinking when I'm modeling. So, there have been a couple comments lately that it's, there's too much information, it's long-winded and kind of roundabout. And if you're looking for a direct to the point, click how-to, this isn't going to be it. So this video is going to be long, and if you want to stick around, then please do. So to get started with this, I am actually going to use mesh section sketches. So we're going to go to our mesh tools. We're going to select mesh section sketch, and we need to pick a plane. So if we zoom out, you can see there's not really any planes on the screen. But what we're going to do is we're going to show the origin, and we're going to just select a section plane as this top plane. And then we're going to pull that down a little bit. Now, the reason I'm doing this is because I want to get a good reference for where that hole is and also the shape that we're dealing with. So -1 millimeter is a bit too much. If I do -0.5, you can see that we're actually getting some of this reference here, and that's exactly what I want. So I'm going to say, okay, create that, hide my origin, go to my sketches, and this last sketch, we're going to right click and we're going to edit. Now, remember when we're doing mesh section sketches, we need to edit them in order to fit curves to this. Now, I know I mentioned that this produces bad geometry, but there are some exceptions to this. So if we're using this for straight lines or arcs or circles, then I think this is a great tool. When we start to use it for open and closed splines, that's where we start to get into trouble. So I'm going to use it to essentially put a circle right there. I'm going to say okay. I'm going to hit D on the keyboard to dimension this at 8.5 millimeters. And then I'm going to use the lock icon to fix the center. So I'm essentially just locking it in place. Then I'm going to use C on the keyboard for a circle. Now I have to note that where the mesh section sketch was is actually at the root of a fillet. So measuring the part will give you a good idea as to what the size is. Now I'm not going to be super particular with these dimensions because really all we're looking at is design intent here. So I'm not going to spend a whole lot of time making sure that all the sketches and details are perfectly created, but we do want to get it, relatively close. So what I'm going to do to start with is say 17.5 for that. I am going to create a line, and knowing that this was a casting and knowing that we've got, some geometry here that maybe is not perfectly represented. So when we're scanning into these corners, we might end up remeshing. You can see that there are some highs and lows in there. So you have these imperfections when casting, especially along a seam. So we'll have to be kind of careful and think about where the geometry should have gone. So what I'm going to do is I'm going to draw a straight line here, and then I'm going to draw a line over here at an angle, right click and say okay. And then I'm going to fillet this corner. So I'm going to use my sketch fillet. And of course, I hit the wrong button. For whatever reason, F for fillet doesn't work in the sketch environment. I wish it would, but we have to just click on the fillet there. Right click OK. And again, I'm not looking for things to be perfect, but I just want it to roughly approximate the mesh. So we can see here the orange is our mesh section sketch. This is our new sketch, and it looks pretty good. It looks good enough for what we're doing. And I'm not going to worry about fully dimensioning this. I certainly could if I wanted to, but it's not worth the time and effort in this video. So we're going to extrude this. I'm going to come up 0.5 millimeter. And what I'm looking for here is to see that some of the mesh, which is going to be kind of hard to see on the camera, I know. Some of the mesh is kind of peeking through the top. This might be a good way to see it. Some of the mesh is peeking through the top, and some of the solid body is peeking through the top. Now, in most of these videos, I generally avoid using a 3D mouse because I've heard that it makes people sick a little bit. So I'm going to use it here for a minute. If you don't like seeing a 3D mouse, please let me know. I'm not going to use it for the entire video, but I thought I would just toss it in here just for fun. So I'm happy with that. I'm going to go 2 different directions. And for the other direction, we want to essentially come down to the bottom. And again, what we're looking for is to see a little bit of the mesh through and a little bit of the solid, which tells me that I've got the approximate overall height, and that looks pretty good. So I'm happy with that. I'm going to say okay. And now we've got essentially the boss feature, that sort of starting point feature. And that's exactly what we're looking for. The next thing that I want to do is I'm actually going to take this and create an offset plane. And while I don't necessarily have to do this, this offset plane is going to help me, sort of figure out where the top of my part is. So 0.5 millimeter is where the mesh section sketch was, and 0.5 millimeter appears to be where the top of my part is. So that's going to be a good reference for me. I'm not going to do another mesh section sketch. I certainly could, and I could pick up some data, but what I'm going to do is actually just start a new sketch on this plane. And I am going to project with P on the keyboard the lines and the arc that I created because I want to carry this off with a line. I'm going to come up and over and just start replicating this geometry. I don't necessarily have to worry about the fillets just yet, but for example, I could do an arc here. Now, if you're not familiar, when you're using the line tool, if you go to the last point and you hold down the mouse button, it'll convert that to an arc. And I'll come back and I'll worry about the rest of that later. Now this looks like it's a straight line for a little bit and then it transitions into a spline. So I'm just going to pick a point, maybe go vertical to this as the ending point for my straight line. We're going to do a tangency between this arc and this line. And I'm going to sort of pull it into place. Again, I'm not going to be real particular with, for example, this divot right here, because on the part there's a little recess for the spring, and that's going to be affecting the quality of the mesh that we got. But this is a good starting point, and we'll come back and we'll use a spline for the rest of this. And now we want to carry this on at the bottom. So line, L for the line tool. And remember I said that we're not going to be building this sort of hook part. We're going to be building the hook shape, but we're not going to be raising it above the boss just yet. So I want to carry this line out. Again, I'm going to worry about fillets later, but for something like this, hold down the left mouse button, convert it to an arc, and maybe come out tangent. We'll come down this way. Again, I'm not too worried about these corners just yet. Hold down the left mouse button and try to convert this to an arc, and then a straight line, and then we'll just sort of adjust from here. So escape, tangent between these two, and hit escape again. And then I'm going to start to just manipulate this and see if I can get it to approximate the shape. Again, I'm not looking to be real precise here. I just want to get it to roughly be the right size. Now, if we are perfectly reverse engineering something, then yes, we would want to make sure that we take a little bit more time and be a little bit more precise with these. Again, for the interest of time in a video, it's not really worth spending the time to do all these dimensions. So if I temporarily hide the mesh, it might also be a good idea to right click, go to opacity control, and just kick the mesh opacity down. Control and 4 will hide the edges. So with a mesh, the edges are actually what is going to give it that dark tint. So hiding the edges and playing around with opacity control can sometimes get you to a good situation where it's easy for you to create these curves without really messing around. And also when we hover over this and it kind of starts to select it, we can right click and make it unselectable, which means that it no longer is going to change when we move the cursor over it. Because we're not using mesh section, because we're just kind of approximating, that can really kind of help out the process as well. So I'm pretty good with all of these. If I want to go back and fillet those, I can. This looks like it makes a little bit of a change before the corner sort of changes. Again, I am not going to be real particular about this. I'm just going to use a regular fillet in the corner. And I'm not going to worry about maybe that transition nearly as much, but it looks like it turns directly into a spline. But I'm going to give it a small straight section first, and then I'm going to transition into some sort of tangent spline. Now, the reason for that is because it's going to just be a little bit easier downstream. If you're trying to manufacture a part, having a true fillet in the corner, something that has a true arc radius that you can use a specific size end mill for example, is going to be a much better solution in the corner than if we are to use a spline through the corner. So now that I have the basic shape, I'm going to switch over to a spline. In most cases, when I'm doing complex work, I like to use control point splines. For this example, a fit point spline is probably going to be an okay solution. And I'm just going to start putting a couple of splines, trying to make sure they're somewhat evenly spaced. But when we get to a tighter transition like this, you're going to need a couple of more points in that area. And then we are going to carry on somewhat all the way to the end. For now, I'm going to go all the way around this ball here. Again, I'm trying to keep the points consistently spaced, but then when we get to tighter transitions, you might need to add a few more. And especially when you get to areas where it's mostly straight, you're going to find it to be a little bit challenging. Right click, okay. And then I'm going to come back and use tangency. We're going to use tangency between the spline itself with that. And we'll do the same thing down here, the spline itself and the straight line. And then we can sort of play around tweaking these until we're happy with the results. It is also important that we turn on the curvature combs. I'm going to increase the density. And what I want to see here is that there are no jagged jumps in the spline. And in this case, because it wraps around itself, we're going to have these overlapping or competing spline curvature combs. But in this area where it's relatively flat, I don't want to see the curvature comb jump over. So what I'm going to do is play around with these points and maybe just manipulate the points until I'm happy with where the curvature combs are. So that looks pretty good. And over here we can see that there is this transition. That's probably okay. Maybe pull this one in just a little bit. But overall, I think this looks pretty good. We can see the curvature here. It looks fairly flat across here, which is telling me that I might want to move this point a little bit. That looks okay. And again, we're not using a mesh section sketch. We're not trying to perfectly change the, or perfectly replicate the part. We're just trying to get close. Also know that there are some contextual options that have appeared lately. So we've got tangent display, which is going to be specific handle to the vertex that we have selected. So you can see we can toggle on tangent display. And then we've also got the curvature display, which shows the change in curvature relative to that specific control point. So for us, what I'm going to do is I'm going to select the entire spline and turn the curvature combs off. Again, I'm okay with getting close enough. I do want to come back and add a couple of fillets in some areas. So for example, this area here, we now have a very small, we've got this straight line, and you can see there was like a little straight line left behind. So I'm going to delete that and connect these. And I want to just make sure that the geometry is nice and clean, and I can come back and add a fillet in this corner. So we have to think about, let's say, the size of the tool that we want to use. We are working in metric here. I'm going to say 2.5. It looks okay. Right click to my marking menu. I'm not too worried about rounding these off just yet, or even that. Overall, I think this is okay. So I think I'm going to leave it at that. We're going to finish the sketch. And now we've got something that we can extrude. Now, remember when we're looking at the front view that we need to have geometry above our sketch plane. You can also see that this sort of tapers down here. So this means that we need to extrude this up and down past the point where we actually need the geometry. Now, this is the reason why we're not going to be building these little hook pieces just yet, because we're going to have to trim this from the side. So I'm going to select this entire profile, noting that we didn't have the opening here, but I'm going to hit E to extrude. And I want to pull this up above that geometry. We're going to go two sides or two directions. And I'm going to pull it down below just to give me enough room. Looks like 15, let's see, 16 is probably okay. And this is going to be a new body. We're not going to join it. We're not going to cut anything. But this new body is going to help us sort of see that. Now remember, we hid the edges. Control 6 will bring them back. But at this point, hiding the edges is probably a good solution. And we might even want to change the opacity of this or hide it for the next part of this. So we're going to create another sketch. And we're going to do this on the side. And this is going to be 0.5 millimeter above our current sketch plane. So I'm going to start with some references. So I'm going to put a horizontal line, and I'm going to dimension it D on the keyboard at 0.5 millimeter below. Now, I could also make it coincident with our construction plane. There are many other things that we can do here, but the main reason that I want to do this is because now I have this sort of horizontal tangent reference. If I double click the mouse wheel and zoom out a little bit, this is going to be, essentially this is going to be the horizontal reference for the majority of our design, and then it's going to sort of come up and over. When we're thinking about an overall design like this, and so for example, if I drag this out, this is a casting. It's not going to be perfectly flat. There are going to be issues with it, but looks like we've got, let's go ahead and make these vertical so that dimension will stay. But even though it's not perfectly flat because it is a casting, when we're recreating this or we're trying to reverse engineer it, we want to think about it how we want to manufacture it. So in this case, I want it to be perfectly flat. So I'm going to escape on the keyboard to get off my constraint tool. I'm going to kind of think about where that transition starts to happen for this section here. And that's something I can actually come back and do later if I want to, or we can kind of decide where that is now. It really doesn't totally affect the design, but I'm going to go ahead and do, let's say, 10 millimeters. And that's where this arc is going to start to come down. So from that point, I'm going to take a horizontal line and sort of figure out where I want that transition to be, which I think is going to be right there. I'm going to say D on the keyboard and let's just say 58.5 millimeters. So this is going to be the section that's going to be completely flat. And after this, we're going to end up mirroring this to the other side because this lever is essentially symmetric with the exception of a little bit of a logo or design on that ball on the end, but it is pretty much symmetric. And then I'm going to take my spline tool. I'm going to come from here. And again, we're looking at these sort of inflection points. I'm going to hold down the control key to take off that persistent constraint so I can get a little bit above that. I'm going to put a couple of somewhat evenly spaced spline points. I'm not going to worry about that ball on the end. That's something we're going to have to add afterwards. And then we're going to use tangency again. Now, you might be wondering, why are we using tangency over something like curvature continuity? Well, curvature continuity with a straight line isn't really going to give us too much. We're not going to get a lot extra out of it. And when we're thinking about machining to a flat surface, tangency is really going to be all we're going to get out of this. It's not like we're making a complex injection mold or anything like that. So taking a tool, let's say a ball end mill or bullnose mill across this and then up, that tangency is going to be essentially all we need in order to get that transition. Now, if you go to like a G2 continuity to the smooth or curvature constraint, it's not really going to buy you too much because we're dealing with a flat plane going, sort of ramping up in 3D. So now that we have this, I'm going to do the same thing on the other side from that point where we kind of decided where it was going to end. And I'm just going to bring a spline point out here, hit escape, and use tangency once more to that horizontal line. And again, all I'm looking to do is sort of replicate a rough approximation of that shape. If I take a look at the solid body, I really just want to make sure those exit the solid body. The next thing I need to do is mirror this to the other side. So I need to figure out where that mirror is going to be. I'm going to do this with a line, just kind of pick a point here, and I'm going to come down, and then I'm going to make a horizontal line. I'll turn these into construction as well. I'm going to give this one a dimension. So when we first started this, we were 0.5 millimeter above this current position, and then we came down 12 millimeters. So it gives us 12.5 millimeters overall. So if I do 12.5 millimeters minus the 0.5 millimeter on the top and minus the 0.5 millimeter on the bottom where that boss is sitting, that'll give me my number. Now, of course, in this case, it's a nice round 11.5, but in a lot of cases, it might not be. So you might want to just do some math in that dialog. And then we can use mirror. We're going to mirror this spline, this horizontal line, and this spline. And it's going to be about that midpoint reference here. And then when we stand back and look, you can see it's pretty close. It might not be perfect, but it's pretty close. And if we want to make some adjustments, we can do, for example, we can make this instead of 11.5, we can say maybe 11.4 if we do it manually, and just see if it gets closer. Now, I'm not going to be too worried about this overall. Now, it looks pretty good. So what I'm going to do is take a vertical line and just connect these two. And this is going to give me a single curve selection for when I use this as a split tool. So let's go ahead, bring our solid body back, and do a split body. Bodies to split will be this extrude. Splitting tool will be this, again, single selection. Extend the splitting tool. And then if we take a look, we've got this upper and lower body. We'll select both of those, right click, and remove. I'm going to use Control-6 to bring my edges back. I'm going to hide the mesh and just take a look at the results. So we're getting closer. Again, we didn't really worry about the ball on the end. If we were going to manufacture this, we might not even want that there. We might just want, this sort of shape here. We'll worry about that a little bit later. But overall, the back side of this, these two pieces match. Of course, we need to get rid of the hole in the center. We can deal with that later. It's pretty straightforward. But overall, I think the shape looks pretty good. There's a lot more to do, so it's a good time for us to save. And then we can move on to adding some more detail. Now, I'm going to leave this boss piece and combine those at the end. I don't think I'm quite ready to combine those, but there are some benefits, some things that we might want to consider. So for example, if we were to fillet this corner and start to pull it out, this could be a potential problem if that fillet ends up being larger and pull away from this corner. If we bring the mesh back and we kind of see where that mesh is, we can see that it really wants to be a bit smaller. And as long as the edge of that fillet, which is going to be kind of hard to see, as long as the edge of this fillet is inside of the edge of that boss extrude, then everything should be fine when we combine them. But if we make this too large and we start to have this sort of corner hanging out, this could be a potential downstream problem that we would want to sort of account for. Now, in this case, it's going to be fine because we can fillet that little corner as well. But overall, these are the kinds of things that you want to be careful with if you're working with multiple solid bodies. Now, I'm also going to hold down Control and add a fillet here. I'm also going to do Control and just add them here, just to sort of add those. This should have tangency across, so it shouldn't be a problem. And we also need to round these corners off. Again, I'm not going to be super worried about perfectly matching that shape. I just want to get it roughly close, and I think that's okay. Again, we'll come back later and we'll build this up. I'm not too worried about that just yet. So with those fillets added, let's go ahead and say okay. I'm going to go back to a home view and do another quick save before we add any more detail. When you get to the point where you start adding fillets on complex shapes, especially if you're using things like variable fillets, make sure that you do save often. In all my experience with Fusion as well as other CAD packages, it's those details like adding the fillets when you have complex splines and curves in 3D that will end up hanging the software up and sometimes crashing. So saving often at this point is really critical so you don't lose anything. Now that we have this saved, we can go ahead and start adding some more detail. And a little spoiler alert, this is actually the next day. I was filming this last night and I kind of sort of gave up on it. So we're going to carry on with the current model, and there are a few things that I want to make sure that we point out that we look out for. So when we take a look at just the mesh, and I'm going to change the opacity back to 100%. We can see that there is somewhat of a consistent fillet on the back side of the part. And when it gets here, things get a little strange. So as it goes into this corner, and again, this is a casting, so we're kind of having to interpret what the intent was. But as it goes into this corner, it gets thinner and it sort of splits. It goes up to this corner here and it goes down this direction. Same thing at the top. We have these sort of rounded sections that blend. Now those are going to be extremely difficult. They're going to be tricky areas. So we want to pay close attention to these edges. And if we were to fill it at this point, it would be a much more difficult process for us to get that geometry. And again, I'm not looking to get this perfect. I'm just looking to approximate it. So what I want to do is I want to think about essentially this point here as a transition between these shapes. And the way that I'm going to do that is I'm going to start by creating a sketch on this top face. And I'm not going to take a look at exactly where the geometry is, but I'm going to use what I created here and essentially carry it over to points where there might be fillets. So I'm going to take a spline and I'm going to find that intersection point. I'm going to find this one over here. And I'm actually going to do, let's say, a tangency with that. I'm not going to worry about tangency over here, but this is going to be where I break the model up. It's not exactly matching what we have here, but again, I'm not looking to perfectly replicate it. I'm looking at design intent. And that's a big thing that you have to think about when you're reverse engineering a part. Decide whether or not you need an exact replica of what you scanned, or if, creating something that is close and has the design intent is okay. So what we're going to do is we're going to split this up and start building that top geometry. And there are a couple different ways that we can do this. We can do this with a split body and essentially just break this piece off, or we can do it with a split face. Now the split face is going to leave this as a single solid body and just break this face up with a division, kind of like we have these faces here. The split body is going to create a completely separate piece, and in some instances, one option might be better than the other. In this case, what I'm actually going to do is split body, not necessarily because I have a good reason, but just because I want to take a look at that as a separate body. Now you will note that it did break up multiple pieces that I didn't want, so I'm going to go ahead and combine those back together. That is one downside of split body with the extended split tool. I could have extruded that as a surface or turned off the extend option. So inside of the split feature, if we disable the extend option and say OK, then it will basically it will only cut that one piece off. So it'll keep the rest of this as one piece. So sometimes you can get away with that and sometimes you can't. You kind of just have to look at your specific instance. I'm going to hide this for now. And this is where it's going to start to get tricky, because this corner, we really need to stay crisp and clean, and we need to start to build out that 3D geometry. So the way that I'm going to do this, I'm going to select this top face, and I'm going to hit E to extrude as a new body. And what I want to do is I want to pull that face up, disable the join. I want to create this as a new body, and I want to show the mesh. So I'm getting approximately the same height. So we can see 2 millimeters isn't enough. 2.5 is probably a little too high. If I do 2.25, looks like we're just starting to see the mesh when I rotate it from this view. Maybe we can see that. You can kind of see there's a little bit of mesh peeking through. So that's about where I want to go. And I'm going to build this as a feature that I can mirror to the other side. Now, one thing that ends up happening that is a bit tricky is we have to taper this face inward. So if I hide the solid body, we have to taper this face inward, and we have to taper this one. So one thing that we can do is we can model the face that we want on the top of this, and then we can sort of taper or loft between the two profiles. Another way that we could do this is with surfaces and splitting the body. Now I'm going to show the surface method and splitting the body first, but it's ultimately probably not the way I'm going to go, simply because we do have all of these curves, and I really need to make sure that I intersect at that point. That's going to be critical, and the surface method isn't going to work in this case, but I always like to give options. So I want to make sure that we have options and we understand how this works. So surfaces, I'm going to go to ruled, and then I want to make sure chain selection's not on. And what I'm going to do is just select a couple edges. I'm going to say this is the direction I want to go. And I've got minus 50 degrees in here, which it's going to be okay. And if I say okay, probably need to extend this side out over here. So we're going to use extend and just bring it out. And basically what I want to make sure happens is I want to make sure that I extend completely through the solid, and then I can use split body. And the splitting tool is going to be that surface. We'll say okay. And if it works, then it allows me to essentially split that away. And if we bring back the other body here, and we bring back this body, that corner still intersects there, which means that when we join this all back together, we can blend and fillet those corners together, and it should work just fine. Now you will note that I didn't do anything with this edge, so that's something that I need to do. Also a quick tip, if you just select a body on screen and hit V, the V key, that's hide, so sometimes it can be quicker than having to go through and find which bodies are here. You will have to go back through and find them to turn them back on, but just hitting the V key can be a quick way to do it. So I'm going to take this bottom edge, I'm going to do the same thing. The direction is going to be the same, and the angle this time is going to be, let's say, positive 50 degrees. And just make sure it goes all the way through. We'll say okay, and then we'll use that as a split body. So bodies to split, the tool is that new one there, and then this piece, I'm going to hit V to hide, and we're left with this. So when we look at this in the context of all the other pieces, we can see that the edge is still where it should be. So we should be able to fillet this. And if we take a look at the mesh, it might not be perfect. You can see we're a little bit high right here. Again, that's okay, but it might not be a perfect solution, but it's actually not that bad. So for example, if I select these two faces, hit V to hide, we can kind of see that the 50 degrees is a bit off. But overall, I mean, it gives us the approximate shape, and that's kind of what we're looking for. The other way that we could do this would be to sketch on this top face, and I'm going to just go ahead and create a sketch. I'm going to finish the sketch. This is kind of like a cheat way to do this. But because we already have that profile, the other way that we could do this is with a solid loft or even a surface loft, and say go from this profile down to this profile. Now, the thing that you're going to find here is when it gets into this corner, you can see that things are getting a little weird. It's not quite the same shape that we got with the surface trims. And sometimes one of these methods is going to be clearly better than the other, but having an understanding that you can do it both ways is a good option. So you can understand whether or not this is the method. But you can see here that the loft, things are actually twisting a bit. And if we pull the points around, you can see that the twist changes. We can see that it's pushing that twist down here a little bit. So in this instance, the loft method, which I thought was going to be a better option, actually is a worse option. And that means that I'm just going to delete that last sketch so I don't have it hanging around. But this means that this is probably the better option, using the surface cuts. Now, if I did everything right, I should be able to mirror that to the other side. So I'm going to create a midplane because I don't have one right now. We're just going to go to midplane, select the top face and the bottom face. And theoretically, I should be able to mirror that. So if I just go to mirror that body, this one here, the mirror plane is that. We should now have a piece that's on the top and the bottom. We'll worry about cutting the middle out in just a little bit. I want to make sure that the fillets and all the blends work well. And now I'm going to go combine, select the main body, and put all of these different bodies together. This is actually a good time for me to also put this body together. I can just select it if I want and say okay. Now, part of the reason I wanted to put that body together is because when I do the fillets, it'll terminate the fillet at that edge, which makes it a little bit easier than going all the way around. So that'll kind of just help me with my selection process. So again, not a perfect solution, but it is a workable solution. And the end goal is something that is relatively close. I know I keep saying that, and I do get comments that say I'm a bit long-winded, but I do just want to make sure we understand that there are multiple ways that we can do this. So I'm going to get rid of these bodies and surfaces, right-click and remove because I don't need them. There's a lot of other stuff in here. These were some of the original lofts and some of the things that we did. Probably keep one of them, and then I'll get rid of these ones here. So that way we're left with the original, which was the mesh section sketch. We're left with the form body, and then now we're working with the parametric body here. All right, so I'm going to hide the mesh, and because they're going to get into doing some more shapes, I'm going to save it because I don't want to lose anything. And now we need to think about or talk about this front face here. Now on the mesh itself, that front face, which is going to be hard to see, I'm going to do Control and 4 to hide the edges. That front face is rounded. Let me rotate it around so we can kind of see. That face is rounded, and we're not going to get that from a fillet. You can almost see that there's a secondary sort of cut that's happening here. Now, if we want to make that shape, that's going to mean we are going to have to break this model up, and that could be tricky. So it could be tricky. I'm going to go ahead and view this from the back, find where these points are, and they look to be vertical relative to each other. And I don't have a point over here, so I need to split this up over here as well. So essentially what we would need to do is build a surface that is going to have the shape that we want on the front. Now, honestly, for a part like this, that let's say the goal is CNC machining, most of the time they're going to be fairly flat on the front, and then there'll be a fillet. So one of the levers I have on one of my bikes for my Supermoto master cylinder is a CNC machined Behringer lever, and it's basically flat on the front and has fillets on the side. So When you get into a non-cast lever, when you get into a CNC machined one, you're going to see that a lot where the front is just flat. So I don't think in this case I want to go real deep down that rabbit hole and start to talk about doing those complex shapes, but I do at least want to give you a little bit of information on how you can do it. So the first way that you would want to do this, and if you're not interested in this, just go ahead and jump ahead in the video. But the first way that you would want to do this is use split face and split this face up, and then sort of work backwards. So the way that that would look is I'm going to create a sketch. I'm going to use project. I'm going to find these points because I already have a nice division there, and I'm going to use the line tool to just connect those points together. And that would let me split the face up, and then I'm just going to do it over here as well. And then using the split face tool, again, we're not using split body, but we're using split face. We'll take that. We'll have to go into our sketches and show that last sketch. And we're going to repeat. And we'll use this. Now, because that has tangency, it's going to split the backside as well. It's okay for what we're doing. It doesn't really have any negative effect here. But basically now what we need to do is we need to get rid of this face and we need to build it how we want it. Now, it's a little bit trickier than that. So before I get too far, the first thing I want to do is turn my construction plane back on. I'm going to go ahead and create a sketch, and this is going to be an intersection. Now, the reason I'm doing this is because I want a curve that represents that sort of midline shape where I want it. And then what I need to do is sketch on the top and the bottom. Now this is trickier because the top and the bottom are not planar like it is over here. Remember we created a spline and we cut away geometry. So this means that I'm going to have to sketch on essentially just a plane that's not the top. And then I want to project these edges that are leading into my cuts. And what I need to do is I need to take a spline, and I'm just going to add a couple points. We'll add some more later. And make this tangent because I want the transition here to still be the same, but I want it to come in a bit further. So I need to start playing around with, let's say, the weight of this handle and where it's going to go. So I need to maybe put that point here. And once I'm happy with that, I'm not spending a lot of time here, obviously, but once I'm happy with that, I would split the top face with this curve. And what this allows me to do is it allows me to start getting rid of this geometry. And I'm going to undo all of this. So again, if you didn't want to do this, then you should skip ahead. But if we're on the surface tools, I can select these faces and delete them. And then I can begin patching this geometry. Now, patch might work just fine if we select this opening and we use this interior rail. So what'll end up happening is we're starting to build that interior rail and give that face some shape. So you can kind of see that it's got a nice little shape to it. And then these edges still match. So when this is all stitched back together as a solid, I'm going to go ahead and stitch all these back together. Again, I'm going to undo this, so don't get too hung up on this. But if I just come in and say, give a 1 millimeter fillet here, now it's failing because there's some funky curvature in that area. But that's not going to work. It does not like that. So what this tells me is because of that complex shape, it's going to be a little bit harder. We're going to have to go down and manually blend these edges. So it's just going to end up making more work. It is possible to do. It's not the most practical method. If you really need that shape, then my suggestion is to, I'm going to go ahead and undo these splits as well. Then my suggestion is to do something like the freeform shape. So if you really, really need to get that shape and that transition, doing the fillets first and then maybe doing a freeform shape and replacing some of those fillets, it might be a better option. But again, as I said, we're looking at design intent, and I'm not really worried too much about perfectly matching that shape. I wanted to mention it because that is probably where we're going to be the most different in terms of the final design and that original. Okay, so at this point, the next part we need to do is we need to think about the fillets or the rounded corners. And this is going to get pretty ugly. And I know that because The geometry that we have over here, and we still haven't cut this hole out, I'm not too worried about that yet. But this corner right here, that right there is going to cause us problems. So when I made this split here, I intentionally made it tangent to this edge, which is likely a bad thing. So what I'm going to do in order to sort of get around this is select that fillet and hit delete, which is going to make that corner sharp, which means that I can sort of work on these independently. So if I hit F for fillet and I try to do a 1mm fillet, you can see that it does that and it ends right here. So I'm going to use this approach and then come back and modify, manually blend this corner. So I think it's going to be easier. And this fillet right here, the test of 1mm looks like it does okay. I'm going to test the bottom as well. And it looks like 1mm does okay top and bottom. Now, if we're talking about manufacturing this with a CNC mill, this fillet doesn't matter as much as, say, this vertical fillet in the corner. Now, the reason for that is because as we look at this thing from the top, if I've got an end mill that's sort of tracing around this, we would want to make sure that any corner here, the radius is going to be slightly larger than that of whatever tool we're using to finish it, so we don't end up getting chatter marks and things in the corners. And we also want it to be a true arc or a true sort of constant radius fillet. It's just going to be the easiest thing for us to machine. Not that we couldn't do it if it was a spline, but it's just going to be easier in terms of manufacturing. This section here, this is a true arc. This was a true fillet. It's relatively small, but it is a true fillet. Now the ones on the outside here, these are going to be blended. And if there is a consistent radius here, we could potentially use a corner rounding tool. But because when we rotate this thing around, it's not planar, tools like that generally aren't going to be nearly as effective. So it would need to be done with like a scallop or a flow tool path or something. So it's going to take a bullnose or a ball end mill to go around these corners and round them off. So it's not as big of a deal if it's like a constant radius thing. So we could change this to chord length. We could go to a curvature continuous fillet. And all these options are going to be fine in terms of the geometry that would need to be machined. But the main thing that I'm doing right now is I want to make sure that I can get a 1mm fillet there. So I'm actually going to hit cancel, go to fillet, and this time we're going to do a variable fillet. So I'm going to select this edge, and the start and end is going to be 1. So the start here I'm going to set to 1. But what I want to do is I want to increase that radius value where it matters. So again, we're not going to be looking at making a bunch of shape here, but what we're going to be doing is maybe just increasing that radius value. Maybe right here, we'll go up to 2mm. And you can see that we're gradually blending from 1 to 2. Now, the 1 here is going to be important because we're going to have to blend this into a smaller radius, probably a 0.5 millimeter in these corners. And the larger radius is going to be good for essentially just holding this thing. So what I want to do is at this corner, I want to see if I can increase that to 3 and maybe do the same thing over here. I'm going to set that to 3 and then maybe back here, set that back down to 2 and then back down to 1 over here. So it's not exactly matching this, the scan that we have, but again, the intent of this part was to look at essentially recreating the part with the design intent. We don't need to perfectly match the scan. We did that, or we took a look at that with the mesh section sketches and using the form tools. In this case, I want to look more at manufacturing a part and not necessarily at exactly matching it. So if you're not happy with the position of some of these, so for example, if we wanted to carry that a bit further, what we can do is we can look for that point in our list and we can move these values. So this is going to be somewhere between 0, which is our starting point, and 1, which is our end. So this is at about 73%. If I make that 0.75, it's going to continue to move that point away. So if we keep increasing this just a little bit, 0.76, 0.77, you can see how it's gradually blending that away. Now this point here, that 3 millimeters, I could also increase this value if the model will allow it. Let's say maybe 3.5, make it a little bit bigger. This one in this corner, I could try to make that 3.5, and if it'll allow it, it'll do it. You can see now we're starting to blend those round sections together. And that looks pretty good. So I'm going to say okay to that. Now we could use the option in the fillet dialog to just add another variable fillet, but I want to do this sort of manually. So I'm going to say 1 millimeter again as sort of the base, as the start and the end. We'll set this to 1 as well. And then at these points, I want to go to 2 millimeters. I'm going to come around here and maybe make that 3. We'll come to here. We'll make that one 3. And then somewhere along here, we'll make this one back down to 2. And again, back down to 1. So rotate it around and just take a look at the geometry. Remember, we can increase these. I think we had 3.5 here. And for this one, we did the same. Was 3.5. And then again, we can move this point if we want to. So looking through our list over here, we're at 0.85 for that point. And this one over here, it's actually the other direction. It's 0.242. So then we would want to decrease this value maybe to 0.23, maybe to 0.22, and just keep moving it until you're happy with the shape. So I think that looks pretty good. I'm going to say okay. And overall, I think that looks pretty good. Without doing a ton of work and trying to get into a complex shape here, I think overall that looks all right. I am going to select the inside face here and just hit delete so I have the hole going all the way through. And before we get too much further, hit save so we don't lose anything. And now we have to sort of address this problem. So again, this is going to be kind of tricky, and I want to start to approach it with constant radius fillet. Maybe do, I don't know if this will approach 1 millimeter. That looks okay. Anytime I do that on one side, I want to make sure I do it on the other as well, because they are the same. We mirrored the geometry. So we're going to right click, say okay. And I'm going to add another fillet. I'm going to try to go around here, see if it'll tolerate 1 millimeter. And again, don't worry about it rolling away here. You can see there's some kind of weird stuff that's happening. But for right now, we just want to just take a look at what the geometry is trying to do. It's trying to leave a pretty nasty edge here. And if we try to blend it into that corner, it's not going to work, which is why we need to come back and do some of this manually. So all I'm really concerned with right now is blending these edges. And again, I need to do this on the bottom as well. So I'm going to zoom out a little bit. And we'll do it there. And also here. Again, just so we're matching top and bottom. I'm going to right click and say okay. And then we're going to try to fillet this, maybe a little bit smaller. Grab this. Do the same thing over here. This edge, that small section, and this one. Blend those all together. We'll worry about this in just a little bit. We'll say okay. And that looks all right. All right, so now a little bit of a moment of truth. We're going to see if we can fillet this corner. And you can see it gets a little bit, once we get past like 1 millimeter, it will not fillet. That's okay. Again, this was pretty tight on the mesh, but really all we're trying to do is round that corner. And then again, we're going to come back and we're going to sort of fix this area. So it's not ideal. It's never ideal to do this. You'll notice there's some weird graphics things going on here. Right now, let's go ahead and just select this and try to do a fillet there. Control select the top and just let it sort of heal that. Let's see if it'll do that one. Yeah, it looks okay. All right. So now, again, as I mentioned, fillets are oftentimes the killer and crasher of CAD. So I'm going to save this and then focus my attention in that corner. Now, when I do this, I want to move into surface tools, because when we start deleting stuff with the solid tools, what ends up happening is it'll automatically try to patch the geometry and keep it as solid. But what we actually want to do is we want this to be a surface, because we want to build those individual surfaces. First, I'm going to go back and add these fillets on the other side just so they match. Grab this one and just blend all that stuff together. You can always use Control and 4 to hide the edges and bring them back just to make sure that things are looking okay. But from the top, Now what we need to do is create a sketch. And we're going to zoom into this area. And what we're going to be doing is deleting some of these faces. So we're going to get rid of probably these faces, but we want to create a boundary that makes sense. So I'm going to start projecting with P on the keyboard, grab this one here, and then I'm going to use just a fillet tool, or I'm sorry, a spline tool, and make these things tangent. It doesn't actually have to be tangent, but in this case, I just want to work with some sort of smooth geometry. We're going to do a split face. We'll split that, make sure we get this little piece here, and same thing on the other side. Now, you'll notice that let's see, we want to grab that, make sure we got that face. You'll notice there's kind of this little spike section there that we couldn't fillet. That's okay, because we are going to delete it. And then the splitting tool is just this. We'll allow it to extend. We'll say okay. And when we extend it, what ends up happening is it cuts this face. If we go back and we turn off the extend split tool, as long as that curve ends at a vertex, a point somewhere on the geometry, it won't need to extend out. But once again, we're in the surface tools, which means that when we delete a face, we're going to convert this solid body into a surface. So I'm going to select the faces that I want to delete. I'm going to go ahead and probably grab that one as well. I could carry this edge. Actually, now that I'm looking at it, I am going to carry that edge up. So we'll make another sketch, zoom in, and we'll grab that point. We'll grab that line there. So P to project. And I'm just going to bring this up here, make it tangent. Again, the tangency doesn't necessarily matter. It matters when you're doing something like a loft. When you're doing something like this where we're going to use the patch tool, it doesn't really matter. But I still like to just use it just in case I decide to go back and do a loft. And then select the split tool. Don't need to extend it. We'll say okay. And now that gives us the faces we need. So we're going to go in here, select all the faces that we want to delete. When we look at this thing from the top down, it can be hard to remember that we've got these side faces here. So make sure you do rotate it around and hit delete. And now essentially what we have is a surface. So I'm going to do this on the other side as well. Just selecting all the faces that I want to get rid of, making sure we grab these side faces and any little pieces that we want to get rid of. So those there, hit delete. And if we wanted to, we could also come back and trim this up. I'm going to see if it'll patch without it. Actually, it looks like I deleted one too many faces. So I'm going to deselect that one. Well, so we're going to see how this thing patches, and then we'll come back and decide what we need to do. So patch, and then I'm going to use group edges and make them all tangent. And again, back to the 3D mouse because it's just going to be easier. And we'll say okay. Not a perfect solution, but much better than what we had before. Now we could do a little bit more work. We could get rid of stuff a bit further up. But all we need to do is stitch these back together. And as long as we see that green border all around, then we'll be good to go. And then do the same thing on the other side. So pretty straightforward process. Select that, group all the edges together, and use tangency. Now, in a lot of cases, you might have to make the decision to use curvature continuity or tangency. When I'm doing a patch like this and I've got essentially prismatic faces, so that's flat, down here, this is flat. Using curvature continuity with those isn't really going to buy me anything. And I found that with patches, especially with multiple edges like that, you end up running into more trouble than it's really worth. All right, so again, not a perfect solution, but not horrible. If I was going to machine this, I would probably spend a lot more time in this corner, probably more time than we've already spent on this model. I might actually go back and hack this thing off and spend a lot more time. I don't think that's really worth it in the interest of time on a video, but just keep in mind that you can certainly spend a lot more time here. And what I've done in the past on models, especially ones that end up getting injection molded, is hack out quite a bit and then maybe blend or loft between, let's say, these two edges with some guides, or maybe from here to here with some guides, and then end up going back and forth and deleting sections of it and patching and so on. So basically what you have to do is figure out how you want to drive that surface and determine what's going to work for you. Now for this hook piece, there are a couple different ways that we can do this. We do still need to probably blend this here. I'm not going to focus too much on it. But for this hook piece, we can essentially just sketch on this face. It is planar. And I'm going to go ahead and create a sketch there. Probably want to flip it around. And then I'm going to bring back the mesh, hide the solid body. And basically what I want to do is just create a slot. Just go and select the slot tool and get it close enough. Again, I'm not super hyper focused on the dimensions for this model. You certainly, if you're going to manufacture something, you certainly do need to make sure that all the dimensions are right. Not really worth it for what we're doing here, but the intent is still there. Make sure that we do go back to the solid tools, E to extrude, and go ahead and pull it through the entire model. We'll say OK. And now we can add a fillet there, pretty small one, 0.5 millimeter. Right click, say OK. And then we also need to add the hole that's here. Now for this one, I'm just going to actually use the hole tool. Make sure that I have drill point turned on. Make sure that it doesn't go all the way through. And then I'm just going to move it around and adjust its size until I can see the mesh underneath and sort of figure out where it needs to be. So you can see now I'm going too low. And if I want to make it smaller or bigger, we can just pull that out. And it looks pretty good. So I'm going to say OK. Hide the mesh, F to fillet. Again, another small fillet. Right click and say OK. And there we go. It looks pretty good. Let's do a quick save. And let's go ahead and let's compare our results. So I'm going to take the original mesh. I'm actually going to try to move it. And just take a look at the two. Control and 4 to hide the edges. And I think from a design intent standpoint, we captured the details that are needed in the hook. We captured the details that are needed in the pivot. And this little spring that helps the sort of the lever pop back. In some cases, it's actually a brake light switch. But those are the critical details. The rest of this is really more about feel. But if we just look at the difference between the fillets that are here and the original, they actually look relatively close. The main difference that we have is that we didn't model the sphere on the end. We certainly could. Now, it's not like it's that big of a deal to add. And if you want to add it after you do the fillets, you can always go to Create, Sphere, pick a plane, and I'm just going to go ahead and model one as a new body. Select it and move it as a solid body. So maybe pull it down. We might need to increase its size. That looks pretty good. And then we can combine these two together. So join them together, blend the intersection between them. It's not going to be perfect. So what we could do is, before we do that, before we combine them, maybe I want to scale this up a little bit. Maybe I want to move it. For the purposes of this, I'm actually just going to scale it up a little bit. Do I want to scale that? No, I don't want to scale it. I don't really like that. But what I am going to do is move it a little bit more. So select the body, M to move. Pull it in. We'll say OK. And then basically what we would want to do is cut away the rest. Now, in order to do that, I'm going to copy and paste that body because I don't want to get rid of all the work that we did. So I'm going to hide that original one. I'm going to use Combine and say Cut. So here's the target body. Here's the tool body, and I'm going to keep the tool. And the reason I'm going to do that is it'll completely disconnect that extra little piece on the end. We can remove it, and now we can join them together. So this will give me a little bit of a cleaner intersection. Now I can blend those together, maybe do a larger fillet. Let's go bigger. How big can we go? Let's see. Yeah, that looks good. So again, now we've got that feature on the end. We could sort of hollow it out on the bottom. That's going to be much harder to machine than, let's see. It's going to be harder to machine than this version. So what we're going to do is just move that, and we'll pull that one back a little bit. All right, so let's go ahead, let's save it, and then we can do just a recap on everything we've done. So when we first started this project, we were looking at using mesh section sketches. And the mesh section sketches were a great way to capture the exact detail of the mesh, but the limitations are in the fact that the actual splines that we got were really noisy. So there's not a great way to sort of smooth or average those out and still maintain that level of detail that we have in the scan. So you could do those manually and get pretty close, but just using those automated tools, unless we're doing things like using the mesh section sketches for a line or for an arc or a circle, when we get into those splines, it just gets really messy. So then we took a look at using freeform modeling. Now, freeform modeling is great because it allows us to come in and attach or pull down to that mesh. So it gives us basically a very low density polygon or subdivided model. And then we can pull down to the mesh at certain points, and we can get extremely close to the shape without all the downsides that we get from using the mesh section sketch. Now, the problem with that on a part like this lever is we actually end up with a problem going to more prismatic features. So like the pivot point, the hook, the flat face on the top and bottom, transitioning from a complex surface, even one that's high quality, into those features ends up getting a little bit messy at the seam between those. So if you're going to go that route for something like this lever, you would want to make sure that you build the surface and freeform out far enough that you can add those prismatic features manually and you can have the underlying surface there. But when we're talking about reverse engineering and we're talking about actually designing or building a part that's referencing that original design, then oftentimes we want to capture specific details. So the pivot point, in this case, the portion of the design that presses on the piston of the master cylinder, maybe a brake light switch or a spring to have it pop back. Those are the critical features that we need, and the rest of the design is really up to user preference. How long the lever is, the way in which the lever bends or contours to the hand. And as I mentioned, there are a lot of levers on the market that are CNC machined in various sort of street bike, dirt bike, supermoto, and they most of the time they're just flat on the front. They don't have the curvature that you get with this cast lever. So looking at again, what you want to get out of the scan is really important. It's going to be a very critical aspect of how much time you spend trying to replicate that design. Now, in most cases, you are probably only interested in some of those key details like the pivots and so on, and other areas are not as critical. So for this, we've mainly focused on creating the approximate shape. And at the end, of course, we added that ball or that sphere on the end. Not very hard to do because we were able to just hack off the end and slap that on and blend it together. But it is slightly different than the way in which the cast one is designed. So again, these are little nuances that you need to think about. Most of the time when you have a CNC machined version of this, it's probably just like this. Now these balls on the end, they're generally hollow on the bottom and they're made to break off in the event of a crash. So that way you still do have a lever and it doesn't just break or bend all the way up here near the pivot. So that's the main reason for those things, to make sure that they don't impale you if you crash, and the little balls on the end generally break off. But I think overall, either of these two final designs here are going to be a good way forward. I could likely 3D print and test these on the bike, not test them like ride it, but test the fitment, make sure that everything fits and works, and then commit to CNC machining a version of this. This also gives us the flexibility to make some design changes. Now, some of the key areas where we had trouble really come down to more of those complex transitions. Now, spending a little bit more time designing these areas and figuring out how they blend together, and maybe not putting that transition tangent to that edge. So that was a design decision that I made while doing it. And ultimately, it came back to bite me. But we still have options like deleting, splitting faces, deleting faces, and blending or patching them back with surface tools to get the end result we need. So at this point, I don't have any intention to try to replicate what we did here with the mesh section sketch or the freeform body. Again, because in this instance, I don't feel like those are the best options. I think that reverse engineering the part with the design intent and using prismatic features is the best way to go. If you have any questions on this is the last episode in this little series here. Please let me know. As always, thanks for watching, and we'll see you in the next one.